Okay, guys, remind me, what does dy dx stand for? When we differentiate, we're finding what? What are we finding? Aliyah, what is dy over dx? What does that mean? Dy over dx. The change in y over the change in x. What is that? That's really what?
Differentiation.
No. We looked at it at the start of class, at the very, very start, like when we now start this topic. What can anybody tell me what does dy dx also mean? It's the change in y over the change in x. What is that?
Um,
What is the change in y over the change in x?
Gradient.
Yes, you're finding for the gradient. Dy dx means gradient. Also, Aliyah, you had to tell me, how come you do so bad in that math test? I don't think that, like, I don't see how that was possible. Like, how? Like, you had to tell me how that happened.
Oh, um, no, she is just mark crazy, and like when you make a mistake for one part of the question, like she don't give you a mark, she just give you 0 in the whole question.
No, but to get 0 out of 45 is insane. I don't know how. Like, I can imagine you getting 0 out of 45. Like, that seems harder than getting full marks. Getting 0. That's crazy. I don't believe it's your fault, but send me the paper. If you have it, do you have the paper?
I had just do the work and I didn't write the question.
Oh, okay.
It's
All
like
right.
practice questions. It's practice test. It's not like coursework, but she just give like past paper questions, and if it and like a 2 mark question in the past paper, she's make it 5 marks. She's
Uh,
give it for 5 marks.
I see. Okay.
Yeah.
So, Aliyah, when you differentiate, you're finding the gradient of a function. Now, when you find the first derivative, you're finding the gradient of the tangent, not the normal. So, um, I'm trying to speed run today. So, so you all could copy this down. And the topic is finding, actually copy down the whole thing. Because you had to notice in regular maths as well. In regular maths, if they ask you to calculate the gradient at a point, what you will have to do is you will have to take the point, draw a tangent to the point, take 2 points on the line, and find the gradient. But in add maths, we differentiate. Kiera, when we differentiate in add maths, we're finding the gradient of the tangent to the normal. Kiera,
If you're repeating,
when we differentiate, are we finding the gradient of the normal or the tangent?
the tangent,
Yes, the tangent. That's correct. So I would like you all to copy down everything you see on the screen here. Right? Amy, let me send you some questions so you wouldn't be wasting your time. Right. Amy, we didn't officially cover it, right? But Amy, if you want to find the stationary points occur when the gradient is. Tell me, Amy.
0.
So I think you can figure out the rest. You know how to differentiate, you know how to put things equal to 0, you know how to do quadratics. You should be able to do it, right?
Mm-hmm.
So I'm gonna send you all the questions and you could just start from my side.
Okay.
Aliyah, do you have the same SBA for maths as Bryce?
No.
No? I was hearing that his SBA is something about a circle.
Yeah. I don't even know like how to
Finding the
do that.
radius of a circle.
Yeah, I don't know how.
What?
Yeah, it's so confusing because first time I hear about SB like that.
I feel like imagine the teacher just don't care. And
He
hey,
don't. He literally don't, and he blaming the students.
and imagine if he just say like imagine if that is just a ruse and that's not actually the SBA and he just don't want to do the SBA. So he just doing
Yeah,
that.
yeah, he's a don't care teacher. He just go in the class and not teach.
Hmm. Don't
And
know.
then he just randomly ask for the SBAs and he don't even teach them. Like, a teacher would like tell you what to do. He don't tell you what to do. He just give you something and you sort of figure it out on your own. And the class kinda slow,
Hmm.
so they
They're
don't know
learning
what to
they're
do.
learning anything at all. They're
No,
not
they're
learning
not.
anything.
And that's why they're doing bad.
Hmm. Yeah, so guys, you all should be copying this down. Yeah, so Aliyah, anytime they ask you to find the gradient of the tangent or the equation of the tangent, what do you have to do with the original function?
Um, Differentiated.
Yes, you're differentiating it. And you know gradient is y2 minus y1 over x2 minus x1. And you know that?
Yeah,
Well, okay, if I take away the final from the original value of y, I find any what and y,
the difference.
or the change in y. So
Yeah,
gradient quite literally means the change in y over the change in x, which means dy over dx. So dy dx is gradient. Don't ever forget that.
yeah.
But it's gradient of the tangent, not the normal. That's not the normal. Not the normal. Right. Amy, I'm going to send you the AdMath solutions, right? So you could correct it. And if there's any questions in particular that's giving you weird round trouble, you could let me know and I'll re-explain it.
Okay.
Right, so as soon as you all have this copy down, let me know. Kiara, are you taking notes?
Yeah,
Kiara, really, really noisy in your background. Everything okay?
I know home right now.
Oh, you're by a friend.
Yeah, one by I was like, oh, I am by one of my friends.
Okay, okay. I think your mom mentioned that. That's all I know. Aliyah, where did you reach?
And the last one.
Okay. So the takeaway from this is when you find if you're asking you for equation of a tangent, a gradient of a tangent, you differentiate the function, and that function, you can plug in any value for x to find the gradient at any point of the tangent. The tangent. Tangent.
I'm not really hearing you because the rain falling real hard right now.
You know hearing me?
I hear you, but like you're soft because the rain falling real hard right now.
Okay. How now?
Yeah, a little bit.
Sound check 1 1.
Yeah, I hear you.
No. Okay, cool. You have all of this copy down?
And the last line.
Okay.
I finish.
Okay, cool. Kira, are you finished as well?
Yeah.
Okay, cool. All right. That being said, I would like you all to try this example. Now, I don't expect all of you guys to know part B, but at least do part A. So for the function y is equal to x squared plus 6x plus 5, find the gradient at the following point. So I'd like you all to try that quickly. Amy, can you tell me where you're starting from? Which question are you doing right now?
2012, question 5. I starting from A. I don't like all.
Okay, no problem.
Yeah. On B right now.
I'll be right back. If you know how to do question B, by all means, continue. Right, Aliyah, any luck?
Well, I differentiate the function.
Right, when you differentiate the function, what do you get? dy dx is equal to,
2x plus 6.
right? Cool, cool. And how did you find ingredients of the first point? So do you know what to do from there?
No.
No? Okay, look at the function. What variable does the function have? dy dx. What is the variable there?
X.
Right. And in a curve, the gradient changes, and the gradient changes at all different points.
Mm-hmm.
Right. So the gradient changes with respect to x. So at different values for x, the gradients will be the same or different.
It'll be different.
Right. So they give you different points, and in those points, and you have a x and a y value.
Yeah.
Okay, which value you think you have to use, the x or the y value?
The X value.
Correct. You're going to use the x value because the dy
You
dx
just,
function. Come on
you
again?
just plug you just plug the X value into the function.
That's all. Those just say
Really?
function, the gradient function.
Well, the gradient function.
Right. dy dx. So you just say 2 by minus 5 plus 6. That's it. So
Okay.
the gradient of the tangent at point minus 5, 0 is that'll be minus 4. That's simple.
Oh, okay.
Right? So this is how it should look. You can copy that down. Any so in differentiation, when we're plugging in a value, we typically draw a vertical line and say whatever the value is. We declare what the value is, and we, we plug it in and simplify. That's always go. Right? So Ali, I have this down.
I'll copy it down.
Okay. And Kiara, did you figure out an answer for the ingredients before I showed it?
Yeah, I did. I get you with it.
Okay, cool. So Alia, quicken up the pace. We have real work to do today. We can't stick. I want to move a little faster. All right. So as soon as you finish, let me know.
Yeah, finish.
Okay. That being said, I want you all to do minus 1, 0 and minus 3, minus 4. Follow the same procedure and send me
Okay.
pictures.
Okay.
Kira, do you know how to find the equation of the tangent at point minus 5, 0? Yes.
Um, Probably. I
All
don't
right.
know.
So, Kira, what are the two things you need to find the equation of a line? What are the two things you need? Kira, you know?
Um,
At least tell me the equation of a line. What is the equation of a line?
Y equals mx plus c.
What are the main things in that equation that you need to know?
Um, the gradient and the my friend saying the y-intercept.
I hear your friend in the background helping you out.
Yeah, she said the y-intercept.
Yes, yes. It's the y-intercept, right? Now, how do you find the y-intercept? Well, to find the y-intercept, you need a point on the line. Well, on the curve. Do we have any points on the curve? Kira, tell me, do we have any points?
Yeah.
Right. So at the point minus 5, 0, so at the point minus 5, 0 right here, you'll have a tangent to it. So this is the point minus 5 comma 0, and we found the gradient. Well, the gradient is minus 4. So you have all the pieces of information you need. There are two ways you could find the gradient. You could use y is equal to mx plus c, Or you could use this thing over here, which is a little more complicated. So you pick your poison. But I guess then you don't know how to do it. Do you know how to do it?
I think if I probably try it, I might be able to do it. Like if I use the first method.
Okay, good. Okay, Alia, that working will not cut it. That working will not cut it. You have to say at minus 1, 0, dy dx, x is equal to minus 1 is equal to this. You have to do the proper working, otherwise you're not gonna get marks. Right? Aliyah, fix up that working fast and send it back. And I want you to write the statements as well. The statements are there for a reason. So you say gradient at minus 1, 0 is 4. So Aliyah, fix up your working and send it back. Right? Kieran, I would like to see your working. I would like to see what you're writing in your book. You know? Yeah. Kirsten, good morning. Good morning.
Okay.
I have almost the same thing. It's just mine a little more scrappy, but I'll send you a picture.
Okay. Okay, Alia, that working still not it. Like, I mean, it had to make sense, right? So Alia, let me explain something. What this statement is saying is that we're plugging x is equal to minus 1 into the dy dx function we came up with. So you need to have
Mm-hmm.
an equal sign because this thing over here is the left hand side and this is the right hand side. So you need to put the equal sign here and say the 2 by the minus 1, etc., etc. The at minus 1, 0 is supposed to be on the top.
Okay.
Exactly how I have it here.
Okay.
Same thing goes for you, Kiara. This over here, this is the left hand side. This is the left hand side. So it's dy dx. You're plugging in x is equal to minus 1. So that will be equal to 2 minus 1 plus 6. And that will be equal to 4. That's what the working is. That's what the working means.
Okay.
Yes, yes. It was like, okay. Kiara, your mom is ever think you give an attitude right now?
It's what?
Does your mom ever think you're giving her attitude when you're actually not?
Yes, because I was talking to her last night,
Right.
and I was like, oh gosh, and she was like, don't oh gosh me. Like sometimes she's take it out of perspective, you know.
I see. All right, so Aliyah and Kiara, I can't move on until I see that Aliyah have the proper working. I need to see the proper working because in the exam, if Aliyah do probably write craziness, Aliyah likely not gonna get a mark, right? So copy down exactly what you see in here. Copy down the correct thing. Alia, did you fix your working?
I'm fixing it now.
Okay. All right. So Kirsten, are you there? I know Kira kind of talk over you. She kind of cut you off. Kira, I should apologize to Kirsten. Kirsten, say hi, and Kira was like, "Whoa, not to."
Wait, what?
I say, Kirsten was saying good morning, and you talk over her. Like,
Oh, I didn't know.
uh,
Sorry.
yeah. So Kirsten, did you ever do this in school? Finding the equation of the tangent?
Yeah, kinda.
Kinda. All right. Well, you know how to differentiate, right?
Yeah, I think I know on the screen right now.
You're taking down one on the screen right now.
Yeah.
Okay. You miss out a little bit, but yeah.
I'll start the record and I get it.
Okay, no problem. But here, but Kirsten, basically what we're doing is we're differentiating the function, and wherever the point is, we're taking the x value from the point and we're plugging it in. That's what we're doing.
Alright.
So we had x squared plus 6x plus 5. If you differentiate that, you'll get 2x plus 6. And then if you want to find the gradient at minus 5, 0, you plug in the x value, which is minus 5. So that'll be 2 by minus 5 plus 6 minus 4. So the gradient at minus 5, 0 is minus 4. Yeah, perfect. Alia, do you know why the gradient at minus 3 minus 4, we call it the minimum or the stationary point? Do you know why we're calling minus 3 minus 4 the minimum or the stationary point?
Because it's 0.
What 0?
The gradient.
Right. Imagine you have a line, right? This portion here, the gradient is positive, negative, what's that? What kind of gradient is that? Positive gradient or negative gradient?
Um, Negative.
Negative. And then over here, it's flat. So it's 0. And then over here, it's positive.
Mm-hmm.
Are you seeing that trend happening here? So like we got a negative gradient, a positive gradient, and a 0 gradient.
Yeah.
Okay.
Yeah.
Yeah. Right. Good. Kirsten, you guys copy down anything by chance?
Yes, sir, I think it's two. Like
All
parts on
right.
the last.
Okay, good. Kira, I trust that you fixed your working. I really trust that. You know, I trust in you a lot. Yeah, I'm gonna move on now. So I would like you guys to copy down this graph. This is a graph for the question. This is a sketch. So Alia, you see in the gradient for this section is negative. The gradient at minus 3 minus 4 is 0 because it's the minimum point, the turning point. And the gradient at minus 1, 0 is positive 4. So you all could copy this down quickly. Amy, how are the questions coming along? Are you getting through them? Are they giving you any trouble? How is it?
Again, true. I reached on 2013 question 5. I checked the solutions for 2012 and I get them correct.
So like the differentiation is no problem there. Like it's easy.
Yeah, I just reached the question with the stationary points.
Right. So by the way, don't let second derivative confuse you, right? It just means that you're gonna differentiate another time on top of the first time. And the notation for that is d2y dx squared. So let me just say you had the original function was y is equal to 5x cubed, then dy dx. That would be 15x squared. And if you differentiate that another time, you would write d2y dx squared, and that would be equal to 30x. You understand?
Oh, so I was supposed to differentiate twice.
Well,
Okay.
well, waiter. You're supposed to differentiate twice for a part 2. The second, so find the second derivative of y,
Okay.
and hence determine the nature of each stationary point. So let me tell you something, right? So if you want to figure out the nature of a quadratic, you would look at the coefficient of x squared.
Mm-hmm.
It's the same kind of thing. So what you're gonna do, right, is for d2y dx squared, what are you gonna do? The value for your turning point, the x value, see like over here is -3.
Mm-hmm.
What you're gonna do is you're gonna plug that value into d2y dx squared, and if that value is more than 0, it's the same thing like with the coefficient. If the coefficient is positive, then it's a minimum. So this would be a minimum. And if it's more than 0, if it's less than 0, is a minimum. Not minimum, maximum, a maximum, right? So if the second derivative is positive, meaning that is more than 0, then it's a minimum. And if it's negative, is less than 0, is a maximum. You understand?
Mm-hmm. Yeah.
So that's a basic rundown of it there.
Okay.
Right. Cool. So, Aliyah, Kirsten, Kiara, did you all get a chance to copy this down?
I almost finished.
Yeah.
All right. I would like to see what you all drew. I would like to see what you all did. Let me see that. Okay, Aliyah, you need to draw the tangent over here. Because remember, when we find the gradient, we're finding the gradient of the Aliyah, we're finding the gradient of the The tangent.
Tangent.
So the tangent line to this point has a gradient of -4. The tangent line to this point has a gradient of 4. So put that in.
Okay.
So the line is what actually had the gradient, you know. The tangent is
Yeah.
what actually have the gradient. That's why you see me draw the line and put the tangent and put the gradient right next to it. So do that as well.
Oh, okay.
Oh my god. Kira, you don't want to put the well, I understand your diagram, but you should probably put the points, you should probably put the coordinates closer to the points. But I trust I understand your diagram there.
Yeah, I understand it, but I had to redraw it and rewrite my notes neater either way, you know. But you know, this is just a scrap diagram, you know.
I want to send that to Miss Stacy. I want to see what she will say. Should I? Kira, what do you think? Should I?
I mean, you could if you want.
I will send that. See what she said. All right. Alia, did you fix up your mistakes?
Yeah.
Okay, cool. So when finding the equation of a line, there are two methods you could use. You could use y is equal to mx plus c, or you could use y minus y1 is equal to m by x minus x1. For the sake of time, I'm going to stick with this method. Y is equal to mx plus c. It's much shorter, much simpler, real easy. So, Alia, what was question B? In question B, they wanted me to do what?
Find the equation of the tangent at the point -5, 0.
Correct. So in order to find the equation of a line, you need a point on the line and you also need the gradient. Do we have the gradient at -5, 0?
Yes.
What is the gradient at -5, 0?
That was -4.
And do we have a point that is on the tangent?
Yeah.
Yeah, because if you draw the curve and they have -5, 0 here, the tangent is here. The tangent passes through that point. You
Yeah.
good? Okay. So I want you all to copy this down, right? I'm gonna actually do back the working. So before I copy down, just pay attention here, right? So Aliyah and Kirsten and Kiara, pay attention to how we're gonna do this. So Aliyah, I want you to stay unmuted, right? So first thing you're gonna ask yourself, do we have a point on the tangent? Yes, -5, 0. That's the x and the y value. Do we have the gradient? We do, as -4. So you're gonna plug the value for x and y and m to find for c. So watch what we're gonna do. So I have y is equal to mx plus c. Aliyah, what do you think I'm going to do next?
You're gonna write in the values.
Okay, so tell me what to write then in the other line.
Y is equal.
Wait. Do we know what y is?
Yeah, 0 is equal to -4. X is -5 plus c, which
Okay,
is
we don't know what c is. That's the whole point of doing this. To find
yeah.
for c,
Yeah.
right? So how are we going to find for c there? How do we find for c over there?
You solve for c, so like
What is -4 by -5?
20.
So what would c be equal to?
C would be equal to -20.
That's correct. And since we know what the y-intercept is and the gradient, we could write the equation of the line. So what is the
Yeah.
equation of the line?
y is equal to minus 4
Minus
x
for what? Right? X. Yeah, continue. Minus 4x.
minus 20.
Right. So copy this up. You think you want to stick to this method or you want to do the second method?
Yeah, I think the first method easy.
Yeah, it's very easy. Right? This is the second method here. Also isn't hard. It's honestly whichever one I choose to use. So copy this down quickly. All right, so guys, we copy down every single thing we see in here, like word for word, detail for detail. You're not skipping anything. Exactly what you see here, copying that down. Ali, are we nearly finished?
I finished.
Okay. Kira and Kirsten, what about you guys?
Almost done.
All right. Aliyah, can you send me a picture of your weekend by chance? Let me see how it is.
Wait, did you want me to find?
I want you to just copy down the notes.
Right, I finished the notes.
Let me see a picture of it.
Okay.
I want to make sure I have exactly what I have on the screen. So Alia, you didn't copy down these steps or anything? Oh, I see it here, I see it here. Find the equation of the tangent at point minus 5, 0, right? Okay. You didn't copy down this part.
No, should I? I could just put it in because it's right here.
All right, so you think you will ever use this method? Are you gonna stick
No,
to this
I
method?
could I could forget the second one.
Okay, well stick to method one.
Yeah,
Kirsten, which method will you use?
Method
Which method?
2.
You would use method two?
Yeah.
Okay. All right. Well, whichever method you all are going to use primarily, copy that one instead. Just copy that. So you wouldn't have any additional things to tie up. Kiara, which method will you use?
Method 1.
All right. Amy, which method are you using? Method one or method two?
Method 1.
All right. So does everybody have this copy down like exactly how it is? Kiara?
Yeah, I have the exact same thing.
Okay. All right. So this is method two. It's the same kind of steps. You need a point and you need a gradient. So minus 5 is x1, 0 is y1. You're just plugging it in. So y minus y1, y minus 0 is equal to minus 4 by x minus 5, right? You simplify and you expand and you get the exact same answer. So Kirsten, this is method 2. Copy this down since this is the one you primarily use. Kiara, Kirsten, have you copied down everything?
If so,
Yeah?
yeah.
Okay, cool. Right. Now we're gonna find the equation of the normal using differentiation. Now here the trick. Aliyah, when we differentiate, right, we're finding the equation of what? What are we finding the equation for? Remind me, guys, when we differentiate, we're finding the gradient of the
the
tangent. So whatever gradient we get, that's the gradient for the tangent. Now, how would I use that to figure out the gradient of the normal? So we're seeing here that the tangent and the normal are perpendicular to each other. Now,
Mm-hmm.
if two lines are perpendicular, how are the gradients related to each other? How is negative 12 and 1 over 12 related to each other?
when you bring wait, I don't know if it's what I think it is.
Shoot. Come
When
on.
you bring the 12 on top, it it I forget what it is called. It is
That's that's with R. You're gonna find the R.
um
Re the
res-
reciprocal.
reciprocal.
Yes. So they are related to each other by the negative reciprocal. So
Yeah.
typically you find ingredients of the tangent first. And whatever you get for the tangent, you flip it and you change the sign. So if you change the sign there, it's positive, and you flip it 1 over 12. So the normal is perpendicular to the tangent. So what you have to do is you have to find the gradient of the tangent first. Then you're going to find the negative reciprocal of that. You're going to use the points given, and you could use either method 1 or method 2 to find the equation of the normal. That's what we're going to do. So I would like you all to copy this down, the graph as well, because the graph will help you all understand what's going on. Okay? As well as the example. So copy everything on the screen right now. So Aliyah, walk me through the steps. If I want to find the gradient of the normal, how would I do that? What do you think we would do?
Ingredients are the normal.
Yeah, how would you find ingredients of the normal?
Um
According to the steps, we have to find first.
Ingredients are the tangent.
And we're gonna do the gradient. We're gonna do the gradient of the tangent.
You could find the negative reciprocal,
Right. And that will be the gradient of the
the normal.
right. Cool. So here what, right? Aliyah, I would like you, so for the example, right? They're asking us to find the equation of the normal at point minus 5, 0. Do you know what the gradient of the tangent is? At minus 5, 0. What's the gradient of the tangent?
-4.
Right. So you're gonna write that down. And you're gonna say, therefore, the gradient of the normal will be what? If the
1 over
tangent is minus 4, what is the gradient of the normal?
1/4.
Perfect. And do you have a point that is on the normal?
Yeah.
Yeah. So the point here, it cuts through the tangent and the normal. So you're gonna use the same point.
So it'll be -50.
Correct. So here what? I want you to finish this question and make sure your working makes sense. So you can write from the previous part, the gradient of tangent. Instead of writing gradient of tangent, you can just write mt. That means the same thing. The gradient of the tangent is -4. Therefore, the gradient of the normal would be 1/4. And if you want to find the equation of the normal, what are you going to do next?
You use the point and you could plug it into y is equal to mx plus c.
Right. Do we have a x and a y value on the gradient?
Yep.
Okay, cool.
And you just
Go
find
ahead.
for C?
Yeah, yeah, that's it.
Okay.
So Kiara and Kirsten, I will probably hear what I say, right? And I would also like you guys to try to finish the example. Kirsten, do you follow?
Yes, sir.
All right. So Kirsten, from the previous part, what was the gradient of the normal? I mean, sorry, what was the gradient of the tangent at minus 50? What was the gradient of a tangent at minus 50? Do you recall?
Negative.
-4, right? And if the gradient of that is -4, what would the normal be? What would the gradient of the normal be? So you change the sign and you flip it. Tell me that one more time. So if we change the sign from -4, it becomes, right? And if you flip 4, it becomes, so 4 is the same thing as 4 over 1. So if you flip that way, it will become
1/4.
correct. So -4. If you find the negative reciprocal, is a quarter. So that means the gradient of the normal is 1/4. So proceed, guys. Proceed. All right. Kirsten, did you finish copy down up to here?
Yeah.
All right. So you're attempting the question now. Yeah or no?
Yeah, I'm not gonna start.
Okay, cool. Aliyah, did you start the question as yet?
Yeah, I finished. I now finished.
Okay, cool. Sunday weekend. I'm gonna check my out. And Kiara.
I just making sure I'm working correct. So you know.
I'm finishing it up right now.
For the diagram
Yeah.
and for the graph, right? I could put the tangent from the question.
Instead, you want to draw you want to draw it suited to this question instead?
Yeah.
Okay, well, if you're doing that, right, you're gonna have to, so minus 5 zeros over here. So you go just draw the tangent here and the normal there, right?
Okay.
All right, so anybody that's finished, I would like to see what you have. Okay, Alia, the tangent is not equal to minus 12, eh? If you're saying that you have to write the equation, m is equal to minus 12, you can't just do that. That means something completely different. You see how you're making those small changes? It's there for a reason, and you can't just change it. If you if you want to say tangent is equal to, you have to write the equation of the tangent, because tangent refers to the line.
Mm-hmm.
M refers to the gradient. Is the
Okay.
line equal to minus 12?
No.
What's the equation of the line?
Um,
What was the equation for the tangent in the first part?
y is equal to minus 4x minus 20.
Yeah.
Okay.
So you have to write m is equal to minus 12, or m is equal to 1 over 12. M is equal to minus 4, m is equal to a quarter. Let me check the working you have here. M is equal to a quarter. So this is 0 is equal to a quarter minus 5. Oh, you make a mistake there, Aliyah. What is a
Wait.
quarter by minus 5?
Oh, minus.
Yeah, that's minus. So
So
C
it
should
should be,
actually be positive.
yeah. Okay.
So fix up that. All right. Anybody else have Wiccan? Clara, Kirsten, Amy, give me an update. How the past papers shooting here?
It going good. When I was doing the stationary points for the first question, I was kind of watching the solutions and understand it, and I doing back on next question with stationary points, and I getting through so far.
Nice. Remember
I
what's
re-
the cubic?
yeah, I remember the shape of the graph that you showed me.
And not just that, think of it as x cubed. So if it's x cubed, when you differentiate, it will become x squared. So it represents a quadratic. So you have to factorize, solve for the two values.
Yeah. Yeah, I'm factorizing right now to find two values for x.
Nice.
Yeah. But I reach on 2014, number 5.
Awesome.
B.
Awesome. So you basically finished with differentiation when you basically done with differentiation. All right. Kirsten, do you have any working to present for this question?
Could you repeat that?
Do you have any working for this question?
I know starting it because I want to help my brother with something.
Oh, okay. Well, I can't wait. I will move on because we have more questions to do. So you can just do the question with me. Right? Kira, don't say normal is equal to a quarter. Say gradient of normal is equal to a quarter. It means two different things.
So like put like MN, just like go up to like the MT.
It's not capital M, by the way. It's a common M. Again, it means different. It means a different thing. So you write M and M and yeah.
Okay.
All right. Yeah. So that's correct, Kira. Nice. Alia, I guess you fix your mistake.
Yeah, I did.
Okay, cool. Right. So send Alia, you have really good working. I want you to send back your working and I'll send it on the chat. So what your working supposed to look like.
Okay.
Right. So I'm gonna do back your working from scratch. Actually, I will leave this working here. And Kirsten, you said you just do the other method, right?
Yeah.
Okay, well, let me do that. So, Kirsten, the first things first, they want us to find what? What do they want us to find?
Equation. Normal.
Right. The normal and the tangent, they are what to each other? The normal and the tangent, perpendicular. If two lines are perpendicular, then how is the gradients related to each other? Kirsten, if we're talking, I can't hear. How is the gradient related to each other? When I change the sign and I flip it, how would I say that mathematically? That's the negative reciprocal. So the gradients are the negative reciprocals of each other. So I'm gonna use it. I'm gonna solve this question using your method. Right, and you'll pay attention. So first things first, from the previous question, dy dx, when x was equal to -5, we found that it was equal to -4. So what that means is the gradient of the tangent is -4. So therefore, the gradient of the normal would be equal to what, Kirsten? Kirsten, what would the gradient of the normal be equal to? Kirsten. Okay, I see Kirsten. The Wi-Fi drop or something. Well, Kiara, let me finish up this question then. So, Kiara, if the gradient of the tangent is -4, what's the gradient of the normal?
If it's -4, it will turn in, like, since it's a minus, it will be 1/4, so a quarter.
Right. Next thing, let we solve it using the other method. So that's y minus y1 is equal to m by x minus x1. Kira, do we have any points on the normal? Kira, do we have any points passing through the normal?
No? No, wait, yes.
How you solve the question then? Did your friend help you?
No, I know. I read over the question now. Yes.
Right. So the normal and the tangent, they pass through the same point. So that's minus 5, 0. Minus 5, comma 0. So in this method, we're gonna call this x1 and we're gonna call this y1. And we're just gonna plug it in. And we know that the gradient is a quarter. So you're gonna say y minus y1, which is 0. All right, and that's gonna be equal to m. M is a quarter by x minus x1 minus minus 5. Right? Y minus 0 is just what, Aliyah? What's y minus 0?
Why?
Right? And let we just simplify the brackets. So we have x and we have minus minus 5. Where's minus minus 5?
+5.
Right? So if you were to expand, you would get a quarter x plus 5/4. Yeah, so this method not even that hard as well. So both methods easy. Right? Oh shucks. Kirsten, can you hear me?
I hear you very slightly.
How about the rest of you guys? Are you all hearing me very soft or can you hear me well?
No, I hear you good.
Kirsten, it might be your Wi-Fi. Kirsten, are you on your phone or your laptop?
On my
I think you should join on your phone. It had less problems on your phone.
join on.
Yeah, join on your phone. It's okay if your cast and my pictures are working. I need to hear you talking class something. That's the main thing. So Aliyah is the second method that's scary.
No.
You just wouldn't remember it. I understand. It's easy
Yeah.
to remember y is equal to mx plus c and
Yeah.
we had to remember that anyways. So you know what I mean, just remember that one.
Yeah.
Yeah. Right. So we finished with the topic. Now we just had to do questions. Right? Yeah. But before I move on, let me just do a recap. I'm going to do a recap. Right. So number one, Aliyah, what does dy dx mean? What is dy dx?
The change in y over the change in x.
Which is basically what change in y? What change in x? Yeah, the gradient. Right? Dy dx means gradient.
Mhm.
And not just any gradient, means gradient.
Gradient of the tangent.
Right. What? Yeah. Tell Malia, what do we need to find the equation of the tangent?
You need the point on the tangent.
Right? So we need a point on the tangent.
Um, you need to find the gradient of the tangent.
Right? And how we just find the gradient? Remind me.
Um, you differentiate the function that they give you,
Right?
and then you're using the x value from the point that they give you to find the
Right.
gradient.
Correct. So you're gonna differentiate. You're gonna find the first derivative. Find the first derivative. Right? So find the first derivative and plug in the value of x at that point. Right. Other question. What does a gradient of 0 mean? What does a gradient of 0 mean? Alia, do you know? What does a gradient of 0 mean?
Is a minimum or stationary point
Minimum or maximum? Because you can have a maximum or minimum,
of 0. Yeah.
right? It means at that point, it means that point, it means point is the maximum or minimum which will right. Well, so we need to know earlier. I also need to find the gradient of the normal. Right? So how do I find the gradient of the normal?
The negative reciprocal of the gradient of the tangent.
Right. So what I need to find first?
The gradient of the tangent.
Right. So first of all, you gotta find gradient of tangent. We know how to do that. Right? Find gradient of tangent.
Mm-hmm.
Then you find the negative reciprocal of that.
I tell him just so.
You okay?
Because hearing you.
Ali, I hear talking now. You alright?
Yeah.
Right? And lastly, how do we find the equation of the normal?
Um, you use the formula y is equal to mx plus c, or the
Well,
other one?
first of all, you need a point on the normal. Now let me ask you a question. The point on the tangent, that's the same point on the normal, yes or no?
Yeah, yeah.
Yeah. Right? So you get the point and you need the gradient.
Mm-hmm.
And then you just use y is equal to mx plus c.
Yeah.
All right, so that's it. That's the recap. So if you all could copy that down, that's everything there. All right, Kirsten, you on your phone? Kirsten, I'm gonna if you're hearing me.
It's hearing you.
Okay, I hear you a little better. So Kirsten, what you might have to do is look back at the recording or copy down the notes. Right?
Awesome.
But since I'm hearing you, and you can talk a little more, I'm gonna give you all questions. I mean, you can try the questions and we can do the question on the board.
Okay.
So here what, I'll can copy down this recap after class. The main thing is I need to see how you do the questions. Right? That's what I need to see how you do the questions. So let me jump straight to the questions. I can copy the recap after.
Um,
All right, so I want you all to try as much questions as you could do. Right? And as soon as I finish with that question, somebody working. All right, so that's the mission. So start now. All right, so Alia, you know what you have to do?
yeah.
All right. Kirsten, you know what you have to do?
Yeah.
All right. Kiara, what about you? Kiara, what you have to do?
I'm finishing. Well, not finishing up, but still doing it.
What you still doing?
The question, and you write it down for us to do, so I started.
I know, write it down.
I was writing and I was starting. So.
All right. Yeah, so do as much questions as you could do and somebody working while you're doing it. Well, if you want to finish with one question, somebody working and move on. Okay, so Aliyah, what you said just now, that's what? What's that?
Um,
What does that seven stand for?
wait, hold on.
Yeah, tell me what it is, eh? That's the gradient of the normal, the tangent, that's the equation of the line. What's that?
That's the gradient of the tangent.
Yes, that's the gradient of the tangent. When you differentiate, you find the gradient of tangent. So here what to do, right? Mn by it. So by the 7, left hand side, right? Sorry, what's it? Not Mn, Mt, right?
MT.
Mt. So the gradient of the tangent is equal to 7. Nice. Nice. Do you have a point that so like this is something that might tie up all you. Do you have a point on the line?
No, they didn't give you a, well, they give you X.
How can we find for y?
Um,
How does that function work?
F of X.
And f of x is really what? What's f of x? That's the same thing as what?
F of 2.
F of yeah, I
Wait,
mean you're getting somewhere, right? But like f of x is another way for what? To write what? Like, okay, I could write a function like y is equal to 5x, or I could write f of x is equal to 5x. So f of x
it's
means,
basically Y.
yeah, it is y. It is y.
Okay,
So
okay.
you could find for y. So
So,
you could
okay,
so you could find for the point.
yeah. Okay.
Amy, welcome back. Amy Yermo.
Yeah.
So Amy, which year did you reach?
I just continue because I had a question. For when you have f of x, right? What's the second derivative you're writing for that?
Oh, f double prime x.
Okay.
All right, Aliyah, did you get value for y?
Yeah, I get 15.
I'm telling you that's correct. Yeah, that's correct.
I get the equation of the tangent already.
Wait, is
And is y is equal to 7x plus 1.
that's correct. That's correct. Nice.
The equation of the normal kind of creeping me out because I get a big fraction. Well, not really like a
Yeah,
big
yeah, yeah. You
fraction.
get a big fraction. You get a big fraction. That's correct.
Okay.
Yeah. It's gonna be all interesting.
Okay, I just can answer you what I have.
Okay. Kira, are you getting through?
Yeah.
Okay. Kira, in this question, did they give you a coordinate?
Yeah.
Where? Where you see that coordinate? In question one.
The no, it's not really I don't know how to explain it, but
What did
basically
what they give you in this question?
they give you the they give you x, well, they give you at x equals to 2, and then they give you the f of x equals the x squared plus the 3x plus 5.
Yes. So we know how functionals work, right? If you plug in x, you get yeah. If I plug x into a function, what is it? Okay, Kira, f of x is just another way to write what? Let me show you. I could write y is equal to x squared, or I could write f of x is equal to x squared. They both mean the same thing. So what is f of x?
X squared.
What happened there? Did somebody scream or something?
Oh, that's my friend's sister.
Oh, yeah, so Kira, y is equal to x squared is the same thing as f of x is equal to x squared. So f of x is really just the same thing as
Y.
y, yes. So that's really y is equal to x squared plus 3x plus 5. So if you have x, can you find for y?
Yeah.
Yeah, you can. Alright, so mt is equal to 7, mn is equal to 1 over 7, equation of tangent, y is equal to mn plus cc. Right. Ah, oh yeah, you make a mistake, eh? The gradient of the tangent is 7. So if you flip that and you make it negative, you change the sign, what's the gradient of the normal? What should it be?
Um, minus.
Yeah, it should be minus 1 over 7. So fix them.
Okay.
So Amy, did you encounter any differentiation questions that gave you trouble so far?
Not really.
Really? That's good to hear. Oh, Alia, you make a noob mistake, eh? Let me show you something. What is okay, Alia? If I ask you what is a half multiplied by 2, you would tell me a quarter.
No.
So with what I just said, see if you can spot the mistake you made. So a half by two is not a quarter. Wait, it's two
Oh,
over two, right?
yeah, it's -2/7.
Yeah.
Oh my God.
Kirsten, how was the question coming along? I'm not hearing you properly. Breaking up. All right, so I'm gonna put on the working for the first question on the board. Actually, Aliyah, send me here what to do. I already have the working.
I sent it back.
Is somebody correct working?
I,
Yeah, that's what you're
I,
supposed to get. That's what you're
right.
supposed.
Okay.
I would have one thing in your working you could improve, right?
Mm-hmm.
It didn't. The function they gave you, it wasn't y is equal to x squared. It was f of x. So it won't be dy dx. It will be f prime x. Remember, um, f prime x is the first derivative of f of x. So you really should I write f prime x? So f prime x would be equal to 2x plus 3. So
Okay.
f prime x means the first derivative, and then you do what? Well, you're plugging into the function.
2.
Yeah, so just make those changes fast.
Okay. I get fixed so the second line dy over dx slash and then the line x is equals to 2.
That over there means the same thing as this. It's equivalent.
Okay, so change it or leave it.
So here what? A way to erase the dy dx is equal to 2x plus 3. Actually, just erase dy dx. Just erase dy dx and put f prime x and erase the dy dx slash x is equal to 2 and just
Mm-hmm.
write f prime 2.
Okay. And move the x minus 2
What x minus?
slash x minus 2.
Yeah, remove that. So
Okay.
let me say something, right? Dy dx slash x is equal to 2 means the same thing as f prime of 2.
Okay.
It means that you're differentiating and you're plugging in 2. So
Okay. I
you're
get
just
what you're
gonna
saying.
you're just gonna replace this with dy dx. So this gonna take the place of dy dx, and this over here gonna take the place of dy dx. X is equal to 2.
Mm-hmm. I send it back.
Yeah, that's perfect. So I'm gonna send that working on the chat. That's the perfect working. Full marks. Right. Awesome. I started class a bit late, so I want to do at least question 2. So do question 2 quickly. Right, so Aliyah, in question 2, they're saying for f of x is equal to x squared minus 4x plus 7, find the equation of the tangent line at x is equal to 2 and sketch the curve for the tangent line. Okay, I give you 5 minutes for that. Take 5 minutes and do that. It's 5 minutes. Kira, I didn't hear anything from you. Did you get through with question 1?
I did, but my phone literally died, like it blank off dead, so I could not send it. But for I could tell you what I get
Yeah,
for the for y I get 7x plus 1 for,
correct.
and then for the normal I get y is equal to minus 1 over 7 x plus 107 over 7.
Nice. That's correct.
Yeah.
And did you use the correct notation? Since it wasn't y, you can't say it not appropriate to say dy dx. Instead, it should say f
I,
prime.
yeah, I used the f prime and then like yeah, the
Okay, great. Right, so on to question 2 now. Right, 5 minutes on the clock for question 2. When I say sketch, what I mean is just draw a sketch. So like, okay, x squared, the coefficient of x squared is positive, so it's a minimum. It will look like that. X is equal to 2. You just draw a sketch. You're not gonna do anything too specific, right? Amy, which year are you on?
2015, question 5, part B. I.
2015, question 5, part C. Oh, I think
Part
it
B. I.
part B.
Mhm.
The coordinates of all the stationary points. So describe to me how to do for that.
Uh, Well, first I find the first derivative.
Nice.
Then, well, I put that equal to 0 since at the stationary points the gradient is 0.
Correct.
And I factorize, and right now I'm going to find 40 points. So I had x is equal to 2/3 and x is equal to 1. So I would find the points.
If say
Mhm.
into the function for y,
Yeah.
right? And to figure out the nature of the each point, you're gonna find the
Oh.
derivative
Mm-hmm.
and whatever. So the points you get, you're gonna take the x value for the points you get, and you're gonna plug it in. If the second derivative is more than 0, that means it's positive, so it's a minimum. If the second derivative gives you something less than 0, negative is a maximum.
Mm-hmm.
So again, it's the same concept with the coefficient. If the coefficient is positive, it's a minimum. If it's negative, it's a maximum.
Mm-hmm. Because any questions before I just say that the point is a maximum or a minimum. Mm-hmm.
Find the second derivative.
No, I mean, I talking about the questions before that was the same thing. You're basically doing the same thing.
So you find the second derivative.
No,
Now,
not yet.
now you had to find the second derivative, like to get your full marks. So you had to find d2y dx squared, and you're gonna plug in. Okay, so what value for x did you get? Okay, what was one of the x values for the point? What was one of the x values for the point that you got? There's be 2 points. So
The x value for one, I get 2/3, and the other one, I get 1.
what you're gonna do is you're gonna differentiate again. So that will be when you differentiate again. Wait, should get? When you differentiate the first time, you get 3x squared minus 10x plus 3. Differentiate that again. I want you to do that for me. So do that now. If you differentiate 3x squared minus 10x plus 3 again, again. Amy?
Wait, you're confusing, man.
All right.
10, 10x.
Here what I'm saying. So to figure out the nature of each point, you specifically have to find the second derivative. Yes, you have to show that working. You can't just say it is a maximum or minimum. You have to see it. You have to find the second derivative. Have you been doing that?
Yes, I was trying to say that before in the questions I did with stationary points, that I was saying that at whatever stationary point that it was either a maximum or a minimum.
By using the second derivative, right?
Yeah, by using the second derivative.
Okay, good, good. So you understand already.
Yeah.
Okay,
Yeah, it
nice.
was confusing a bit.
I thought you wanted me to re-explain it, or you didn't understand it fully. Sorry.
Yeah,
Well,
that's okay.
So you're basically good to go with differentiation then. Okay, good. Um,
That's Sonia answer, but I don't know if that's correct.
let me see. So the first derivative is 2x minus 4. F of 2 by 2 is 4 by 4 minus 0. All right. So Aliyah, if the gradient is 0, right? What does that mean? Is remember, I make you in the recap, we wrote
It goes
something
at
down.
stationary point.
Right. So
So
another
that
thing. And wait, another thing. If the gradient is 0 and you put 0 in front of x, what's 0 by x?
0,
So y is equal to
0,
plus
3.
y is equal to 3. That's a horizontal line or a vertical line.
Um,
Let me draw the watch.
that could be,
It's a horizontal line. That's a horizontal
yeah,
line passing through y is equal to 3.
yeah,
And it makes sense because it is a minimum point, right?
yeah.
Yeah. That was just a question to make sure to see the follow. Yeah. So I see you want to write y is equal to x plus 3.
Yeah,
Or what was in front of the x? 0.
0.
So fix up.
Okay.
That being said, I think you have time to do question 3 because it's now 12:07. Take another 5 minutes and do question 3. These questions won't take long. Yeah, that's what it's supposed to be. That's correct.
Okay.
And just follow the point.
Okay.
Follow the point there. And if you want to be really extra, um, actually you had to do this. You had to do this to get your full marks. You need to show the minimum point. So you have x is equal to 2. You just plug 2 into this to find y. And you put your point and you draw your line. Y is equal to 3 to get your full marks. So just go ahead and find go ahead and find the y value when x is 2.
I do that. Did
Uh,
I?
yeah,
Yeah.
did you?
Yeah, y was 3.
Yeah, okay. So then
It's
your
3,
point
3.
would be 2 comma 3
2? Oh,
because
yeah, the X. Yeah.
yeah, cool. I'm gonna make sure that's what I had. Yeah, 2 comma 3, perfect. All right, try question 3, 5 minutes.
Uh, okay.
No, you can do it, just think. Lock in.
They're saying that the tangent is parallel to the line. Y is equal to 2x plus 5. That line is not a normal.
Wait, let me understand what it's saying. So they want you to find the points on the curve where the
Oh,
tangent is
oh.
parallel to the line. Let me try to understand what it's saying, right? So you have a curve, right? You have a curve,
Mhm.
and the tangent, we don't know where the tangent is, but it's saying the tangent is parallel to the line y is equal to 2x plus 5. If two lines are parallel, what do we know about them?
Um,
Try to remember, if two lines are parallel. Remember, what is gradient again? Gradient refers to steepness, no?
Yeah.
So if two lines are parallel, this is what it means.
They don't ever meet.
Well, they don't ever meet, right? But that not gonna help us on this.
No.
What do we know
This
about that? Okay, so perpendicular lines, the gradients are the negative reciprocal of each other. But what's the relationship between the gradients for parallel lines?
is the same thing.
It's the same thing.
Yeah.
That is all I will say. So find the points. So in this question, you have a curve and you have a tangent. You just don't know where your tangent is. But it's saying the tangent is parallel to a line y is equal to 2x plus 5. And what we know is if two lines are parallel to each other, what is the same?
The gradient is the same.
Where's
So
the
the
gradient of
gradient
this line?
2.
Where's the gradient of the
So
tangent?
2.
Right. So now you need to figure out the points. Now you need to figure out the point.
Find for y.
Say that again.
I just have to find for y.
Um, you-
No.
X and Y.
Wait.
Well, let me try to understand how we're gonna do that. So you have the equation of the curve,
Mm-hmm.
and we saying that the gradient of the tangent is 2. So that we know that, right? And we know that.
Yeah.
What is 2?
The gradient of the tangent.
Right? And we also have f of x.
So you could find
Let me think. So we know that the gradient of the tangent is 2. Now, if we didn't know what the gradient of the tangent was, what would I have to do? How do you find the gradient of the tangent?
to differentiate the function and and plug in the x value.
All right, you're getting somewhere. We don't have any x values to plug in, right? But
Mm-hmm.
do we know what the gradient of the tangent is?
Yeah.
And do we know how you would also do we know how you would find the tangent?
Yeah.
So
So you put the gradient equal to the function when you differentiate,
yes, because
and you find for x.
t, listen,
You find for x.
correct. That's it. And once you find
Okay.
for x, you can find for y.
Find for y. Yeah.
Right. So Alia, how is it going?
I get I get the values.
So let me understand how this work, right? Because you was able to figure it out, but you need to figure it out when I know there any exam with you.
Mm-hmm.
How did you how is this question working? Like what was the process behind it?
What do you mean? Like,
So run me through it. Like what how would you have to think to come up with the solution? So I want you to go through the question, assess it, and understand what they're asking. So read the question.
find the points on the curve f of x is equal to x squared minus 2x minus 3, where the tangent is parallel to the line y is equal to 2x plus 5.
All right. What are they giving us?
They give us the function.
Right? They gave us
They
one.
they tell us that the tangent is parallel to the line y is equal to 2x plus 5.
Okay. What could we take out from the information they gave us?
Um, you could take out the gradient.
Explain.
Um, well, they say the tangent line is parallel to the other line, which
Right.
means, and they give you the gradient of that line. So that would mean that the gradient of the tangent is the same
Correct. Because
because
they're
it's
parallel.
parallel.
I like where you're going with this. Continue.
So you could use the function, and they wanted you to find the points on the curve. So you could use the function and put that equal to the gradient, because in order to
No, 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 no.
find,
Nah, nah. That's what you do. I'm gonna check what you do.
yeah, that's what I do.
Um, oh, you do the correct thing. You just explained it a little wrong. Um, you're not gonna put 2 equal to f of x. You're gonna put 2 is equal to what?
Um, f prime of x, sorry,
Right.
my bad.
Because
Yeah.
f prime x represents what? What does f prime x represent?
Um, when you differentiate the function,
Right. It specifically means the gradient of the tangent.
yeah.
So we have a gradient of the tangent. We're gonna find an expression for the gradient of the tangent. And
Mhm.
to next.
When you find for that, you'll get your x value,
Mhm.
and you could find for your y value.
Correct. Using the function.
Yeah.
I'm gonna tell you if your answer is correct. 2 minus 3. Excellent. I'll send you working on the chats. Well, you said send you working for 1, 2, and 3. Because your working for all questions was good so far.
Okay. Well, you send one already.
So you think question 4 is similar to question 3?
Find all the points. Um, I think so.
You think so? And you need to be confident. Either yes or confident no. In question 3, let's look at what they gave us. They gave us the equation or the function, and they also gave us there was a bit kind of you had to dig in to find it. But what did they give you in this line? They said where the tangent is parallel to that. In summary, they gave you what? What did they give you there? They said where the tangent is parallel to the line. So by doing that, what did they give you?
The equation of the line,
Nah, not the equation of the line. I would really care about that.
the gradient.
Right. This all of this. Okay, like
Mhm.
how You know how it had this running meme for like women, like when they had to say this sorry, they do all this
Mm-hmm.
before reaching here,
Yeah.
and men they just go like that. Okay, it's the same situation over here. Instead of telling you that the gradient of the tangent is 2, instead they give it like this, right? So in this question, they gave you the equation of the curve, and they also gave you what?
The function.
The function is the equation of the curve.
Oh, and the tangent.
What's
The
of it?
gradient.
What's of the tangent?
Gradient.
The
Gradient.
gradient of the tangent. So that's the two things they gave us, right? They gave us the function and the gradient of the tangent. Is this question any different? Read that question.
Find all the points on f of x equal to 2x squared minus 3x plus 1, where the tangent has a slope of 5. It's the same thing.
It's the same thing because in this one, it's like this is you and this is Bryce.
Yeah.
This is you and this Bryce. So I
So
think
it's not the same thing?
I'm confident that you could figure out question 4 that real simple and the same steps as question 3, right? Before class finishes, I just want you to try 5, and that'll be it. No bother with 4. You know how to do 4, right?
Okay.
So try question 5. Amy, are you still with us?
Yeah. Question 2016, part B.
Wait, wait, speeding, wait.
Yeah.
All right. You have and advanced exam soon?
I don't know. You mean for marks?
Yeah, the one you said you wanted to do.
We don't have a timetable. Usually, what does happen? They like to send the timetable last minute, so we might get the day before mock starts. So
So you don't know when exactly you're gonna write the exam.
no, not at all. And one of my teachers said that they didn't even discuss timetable yet,
What the
and
hell?
mock then on the 17th.
Slack boy. Hey.
Yeah, there's always do that.
Well, all right. Here what? If you can, try to do all the differentiation questions. So
Okay,
do all the differentiation questions for tomorrow. We can move on to integration.
okay. Because I'm still not sure if I'm feeling prepared enough to write the exam, even though like we have a little bit of time, it's still hard to do for my other subjects too, you know.
That's true, huh?
I don't know when the exam is. Because if it's around the end of the month, I would be like, okay, that good, but I'm not sure.
Well, here what? I ain't really concerned with how you do. I know you could do good, obviously. I just wait to do the exam to experience how the exams be in a class setting. That's all I want.
Yeah, that's what I was thinking too. So I think I would ask maybe after sports day, because right now they doing a lot of preparation. So I don't think nobody really caring right now. So maybe
Oh,
the following week I
well,
will.
we'll ask and see what they say because I just wait to get up that in-person preparation kind of thing. I want you to get an experience. And if you don't do well in the test, well, you can take the test, you can do it on your own time, fully understand it, and I can give you back a test and you can do it.
Okay.
You want to create like a sample test for you and you can do it? Test on all the topics we did so far.
Yeah. Mm-hmm.
The only topics we didn't do is integration, kinematics, statistics, and probability. That's the only things we didn't do.
Okay.
All right, Aliyah. What we on question 5? Tell me.
I don't know. I get f prime of x.
Now this question a bit tricky, yeah? So earlier in this question, you think the way to find the point for the tangent or the normal. Tell me. So find the points on the curve.
Normal.
So that again, you're confident, right? Normal, right?
Mm-hmm.
Because you're not seeing tangent anywhere.
No.
And they're asking you to find the point on the curve where the normal is perpendicular to the line y is equal to half x plus 3.
Yeah.
So we know we had to find out. This is the hardest question I could have come up with. I think one of the hardest questions. So yeah, we clearly need to find the point of the normal. Okay. And they are telling us that the normal is perpendicular to this.
To the line. Yeah. And it could be the negative reciprocal
Yeah,
of the gradient.
yeah. I like what you're thinking. So if the normal is perpendicular to that, what would the gradient of the normal be?
It could be -2.
Yeah. Now let me see what you're gonna do next. That's it.
Um,
Are you going to what are you gonna tell me what you're gonna do next? What's the next step you would take?
um, find f prime of x. I don't know.
Okay. So let me think about it logically, right? You tell them to find f prime x. F
Yeah,
prime x is the gradient of what? When you find the first derivative, you find the gradient of the.
tangent.
So when you find f prime x, will
You need
that
to find
so wait, when you find f prime x, are you finding an expression for tangent or normal?
tangent.
Okay, we're gonna stick with that, right? No worry.
Mm-hmm.
Makes sense. So f prime x. Okay. So next thing, we're gonna find f prime x. We're gonna find f prime x. But what is f prime x?
2x minus 4.
Right, but more weight is though. Like is a gradient of the normal, is a gradient of the tangent, weight is.
That tangent. But you don't need to find.
It will make sense, don't worry. Watch this. So how we find f prime x? F prime x is equal to what?
2x minus 4.
And that is what I would use if I want to find a gradient of the tangent, right?
Mm-hmm.
Hmm. I want you to think of 2x minus 4 if it was a number. It's the same concept. Like, okay, if the gradient of the tangent is 5, what's the gradient of the normal?
Minus 1 over 5.
Right, I think I'll give you the answer there. So if the gradient of the tangent is 2x minus 4, can you figure out an expression for the gradient of the normal?
Um, I think so. It could be. Wait, that could be
So think of this whole thing here as one term and as a number. 2x minus 4, that's a number.
minus
So
1 over mm, minus 1 over 2x minus 4.
that's correct. You understand, right?
Yeah.
Yeah. So the gradient of the tangent is 2x minus 4, but the gradient of the normal is the negative reciprocal of it. So minus 1 over 2x minus 4. And so what we could do now? Do we know what mn is?
Yeah.
So what we could do?
Um.
It's very similar to question 3 that I did. So and you would have differentiate it and put 2 is equal to 2 is equal
So
to the
you put it equal to a half
half.
because that's the gradient of the line.
No, what's the gradient of the normal?
What was that?
What's the gradient of the normal?
Minus a half minus 1 over 2x minus 4.
That's the expression for it, but what was the gradient? What was the actual gradient of the normal that we found?
Oh, minus 2.
Right, so we could say minus 2 is equal to minus 1 all over 2x minus 4. And then what we're going to do next,
Or you could cross multiply.
right? And you're going to end up with minus 2 by 2x minus 4 equal to minus 1. So that'll be minus 4x plus 8 is equal to minus 1. You move across the plus 8. Minus 1 minus 8 is minus 9. You divide both sides by minus 4. So x is equal to 9 over 4. Right. If x is equal to 9 over 4, how would I find for y?
You could use the function that they give you and plug x in.
Right, so that'll be 9 over 4 squared minus 4 by 9 over 4 plus 6. And when you plug that into the calculator, you should get 33 over 16. Yeah, 33 over 16. So your point is 9 over 4.
Minus 9 over 4.
No, minus 4 and then minus
Oh,
9 divided by minus 4 is positive.
it could cancel off.
Yeah, you'll cancel off. Right, that's the answer. Now, I believe there was another way you could have worked this question. I'm gonna try something real quick. So, half is equal. Yep, there's another way you could have worked the question out. I just put on the other method, and I can explain the other method next class. So, Aliyah, you understand this method, right?
Yeah.
Okay. The next one I'm gonna show you, right? Max, that question. When So the point, right? If you have a tangent and a normal, and this and point that's cut through both of them,
Mm-hmm.
yeah, that point is common to both of the lines.
Yeah.
So they say any normal to the curve is perpendicular to the line y is equal to a half x plus 3. So if it's perpendicular, then it will be parallel to the tangent, no?
Yeah.
I kind of hard to understand. I kind of hard to visualize, but here what I'm saying. So they're saying the normal to the curve, so you have the normal, and that is perpendicular to some line, a half x plus 3, right? Like if you were to overlap them, you see they're perpendicular, right?
Yeah. Yeah.
So imagine you have a curve and you have a normal. That's not normal. You have a normal here. And they give you some line on the outside. They give you some line. Earlier, you can see that this line perpendicular to this line, right? Just,
Yeah.
yeah. But it's just over here, right?
Mm-hmm.
So if I were to draw the let me draw the tangent. That tangent will be parallel to what line? Check it out.
To the normal.
Not to the normal. This is the normal here. The normal is the blue line.
To the tangent.
So the tangent will be parallel to this line over here.
Yeah.
And so this is what happened. They said the normal to the curve is perpendicular to the line y is equal to half x plus 3. So they
Yeah.
gave us, so we have the normal. This is the normal here, right? And this is how the tangent to the line would look.
Mm-hmm.
And they said the normal was perpendicular to some other line. So if this is the line they gave us, this is the line here. This is y is equal to half x plus 3. And y is equal to half x plus 3 would be parallel to the tangent.
Yeah.
It would. Amy, I want to show you that real quick. Amy, that
Yeah.
is the last thing for today, right? So Amy, look at this question. So when we did it in class, we did it this way, but there's another way to do it. And I just realized they are saying that the normal is perpendicular to the line. So if the normal is perpendicular to the line, then that means it will be parallel to the tangent. Because watch, if this is the normal and this could be the tangent,
Yeah.
and they're saying that they gave us some other line, and the line that they gave us is perpendicular to the normal. Now it doesn't matter where this line is, it will always be perpendicular to the normal, right? So Amy, look at it, right? This is the line y is equal to half x plus 3. This is the normal, and this is the tangent. And you can see that the tangent is parallel to the y is equal to half x plus 3.
Yeah.
Yeah. So if that's the case, then the gradient you get from this would also be the gradient of the tangent. Isn't that so?
Yeah.
Because this line is parallel to this line. And if you know the gradient of the tangent is a half, then you could just find the first derivative, which is the gradient of the tangent. You could substitute that the gradient of the tangent is a half, and you could find for x. Yeah. Next class I'll go into one more detail. I feel like our brain saturated. We do a lot of work today. Aliyah, you kind of understand? I know we do a lot of work today.
Yeah. But
Okay. Um, so next class, I'll just go over the questions in detail and we'll move on to stationary points.
okay.
Um, so that's it for class today. So I hope all you have a blessed day. Thanks for coming to class, guys. Later, everybody.
Bye.
Bye.